All right. Hello there, students. Let me get set up here. Um, we're going to be talking today about the concept of parallel lines once again. And today we're going to kind of work in reverse. We're going to talk about the angles necessary to make the two lines that are cut by a transversal parallel. So it's all based upon a converse. A converse is basically the reverse of a statement. If you have two parallel lines cut by a transversal right here, and then you have corresponding parts or pairs of corresponding angles are congruent, well, we're just going to write that in reverse. So if we have then if pairs of corresponding angles are congruent, then two lines cut by a transversal are parallel. Okay, so basically it just switches the if-then part of the statement. So this is the then part, which was the if part before, and the if part was the then part in the original statement. So basically what that allows us to do, as you can see, I'm in the car, so I'm trying to make sure that I'm not going to have the greatest handwriting in this concept. So if you're taking notes, and if you took the notes on 10.3 and you're looking for the ability to figure out what are we trying to do in this particular section, it's to say, well, I have two corresponding angles congruent. That means that those corresponding angles, when they're cut by, if they're formed by cutting a pair of lines with a transversal, those pair of lines are going to be parallel. All right. It doesn't make sense. All right. It doesn't make sense to be able to draw two lines that obviously aren't parallel, cut it by a transversal, and then to say, something ridiculous like this angle here and this angle here, which are corresponding, for those to be congruent. It just doesn't make sense that way. So if you were to shift this around and potentially even make it, a different, we'll change the aspect ratio of that and try to make this, more of a parallel line. Well, then you have this new angle right there and right there are going to be the same. Okay, so parallel lines, think of a railroad tracks, think of you guys know what parallel lines are. So we're gonna work with this stuff, and hopefully this stuff is not that difficult of a concept. The same thing works with alternate interior, alternate exterior, and consecutive interior angles. Making sure that consecutive interior angles need to be equal to 180 degrees for them to be equal to, or for them to be parallel lines. Okay, so we're going to come down here to the extra practice in the student journal. And the extra practice here is a set of 6 problems, which asks you to use your intuitiveness to say, okay, here is an angle that they call 8x plus 55. Here is an angle that they call 95 degrees. And we're going to try to make those equal because they're corresponding. And if they're corresponding and they're equal, well, then M is parallel to N. Okay, well, we don't know that yet because X could be 1, for instance. Like, let's just, over here before we do the problem, let's just say that if X is equal to 1, we're just going to give you a random number. Well, then 8 times 1 plus 55 is 63. Well, 63 is certainly not equal to 95. So therefore, M is not parallel. I don't want to even write that, to be quite honest with you, so, we're going to, basically M and N are not parallel. All right, figure it out. Okay, so I think that, how to write that would be that M is not parallel to N. Okay, so this is an example of what it means for it not to be parallel, and we want to find that X value, all right, that does make it parallel. So we're going to set up the equation in a little bit different way. All right, over here on the right. So number 1, we're going to set up 95. And we're going to make sure that that corresponding angle is equal to 95 by setting an equation equal to that. Okay, so now we're going to get some simple mathematical solving steps here. 95 minus 55 is going to be 40. 8x. X is equal to 5. If X is equal to 5 in number 1, then M, if X is equal to 5, then M is parallel to N. Okay, so that's exactly what we're doing. Number 2, right above me there, is the same type of thing. These are alternate in exterior angles. We know those to be congruent. If M is parallel to N, you can see the transversal. You can see the angle on the outside of the parallel lines here and on the opposite side of the transversal. Those are alternate exterior angles, and we need those to be the same for M to be equal to N, or not equal to N, but M to be parallel to N. All right, so we're going to set up the basic equation. 130 is going to equal 200 minus 2x. All right, we're going to subtract the 200, so that's going to be negative 70 is equal to negative 2x. X is going to end up having to be some value that will create a positive angle over there. We don't want it to make a negative angle. That doesn't make sense. But then X is going to equal positive 35. So you can make a statement that says if X is equal to 35, then M is parallel to N. Okay? So that's how you do number 1 and number 2. That should give you some feedback on how to potentially do some of the problems in your homework set. I'm not sure exactly how number 3 and number 4, number 5, number 6 correspond to homework set problems, but I am going to do them. And the objective, all right, just to kind of do some erasing here. The objective of what we're going to try to do in number 3 is to decide whether or not there's enough information to prove that M is parallel to N. So now we have R is the transversal. So here's my transversal. All right, the 2 angles that are in question are the 2 angles that are identified here, right there, and right here. Okay, so if you were to categorize those as congruent, because those are the congruent markings that we're going to be looking at, we would say that those are corresponding angles. So I would say that M is parallel to N, and I would use the corresponding angle theorem. And that's a pretty low level proof, just basically stating a justification for why you think that M is parallel to N in that particular case. Okay. In number 4, the angles in question, or the angles that the diagram is asking you to be congruent, right here and right here, they are not formed by a pair of opposite or intersections. So that's in the same intersection. So if I drew line R, for instance, and just try to copy that line R, and I just drew M, okay, I would then be able to duplicate what angles that it's referring to. That's referring to this angle and this angle. Well, what two lines are we trying to prove parallel? We're trying to prove M is parallel to this line N, and therefore those two particular angles being congruent, even though they're vertical, aren't going to tell us anything about the concept of M and N together. So just to kind of erase that thinking or that thought process right there, we're not going to make a statement that those lines are parallel, because the two angles really don't have anything to do with each other. Okay, so we're going to say that there is not enough information. There is not enough information. Okay. Cannot make a determination whether M is parallel to N in that particular case. And look at number 5. Number 5, I'm going to go, basically we're talking again about one intersection. If that's an intersection of 4 streets right there coming together, that's just one intersection. Those angles are not going to tell us anything about the concepts of whether M and N are parallel. It has nothing to do with N. All right. Number 6 does have something to do with N. We have one particular congruent angle that is an intersection between N and R, and another particular intersection between M and R, and those would be considered alternate exterior angles. So we're going to be looking at this as M is parallel to N because of an alternate exterior angle theorem. Okay, and that's exactly kind of what we're looking at doing for the extra practice on 10.3. We're going to compare angles so that lines can be parallel. All right, thank you, and that should be enough of information for you to continue with 9 point or 10.3. Thank you very much.